Okay, so this is a brute force direct calculation, and step one, parameterize the surface. Okay, well, step zero, draw a picture of the surface, and step two, parameterize it. Right? So, conveniently, by the way, the big hint in the statement of the problem is that the surface is the graph of a function. So we already know we can use the graph parameterization, unless something else better comes along. But I don't think it will in this case. This thing looks like this. There's our surface. That's the portion of this graph that has z positive, greater than or equal to 0. So, in fact, that's the portion sitting above this disk. That's the disk where x squared plus y squared is equal to 4, namely 2 squared, so the radius is 2. And so we can parameterize by u comma v comma, and then we're doing the graph parameterization, so 4 minus u squared minus v squared. Right? Okay, so now we've got to compute our normal vector, so xu is 1 comma 0 comma negative 2u, and xv is 0 comma 1 comma negative 2v. Then our capital N vector, cross product. Okay, so I have 2u, no, let's see, wait a second. 2u, comma, 2v, comma, 1. Okay, so there's our capital N vector. Okay, now check. The problem says that we want the surface to be oriented upward. Did this orient it upward? Yeah, that's positive. So this is oriented upward. In other words, we did compute we've got a capital N that corresponds to a unit normal vector, little n, that is pointing upward, as opposed to, there was a possibility we might have inadvertently done it upside down, but that didn't happen. So, good. Okay. Everybody happy? Okay. All right, so we're computing flux. That's integral over the surface of f dot ds vector. Well, that's integral f dot n du dv. Oh, excuse me. Now this is an integral over this disk down here. Let's call this disk d. Integral of d. And this is just a double integral at this point. Now, what is that double integral? Well, let's see. The vector field is zxy. Well, wait a second. What are x, y, and z? Well, here's x, y, and z. Right. So zxy is the following. Z, X, Y. So there's our vector field. Our n vector is 2u, 2v, 1. And you can multiply out this dot product, and you get a polynomial that you're going to do a double integral of over that disk of radius 2. Centered at the origin in the UV plane. And is that cool?
Yeah.
Okay. That makes sense to everybody?
So with the bounds for the second, I guess the nested variable, so it'd be 0 to, it depends, so it'd be like negative 2 to 2. And
Yeah, negative 2 to 2 for whatever the outside variable is, and then, square root of 4 minus v squared in this case. Plus or minus.
Plus or minus.
Yeah, right. Yeah, exactly. And you can. By the way, this is a round domain, so one thing it's possible, and I can't quite do this in my head here, but it is possible that polar coordinates might be convenient for this. Then you don't have to deal with square roots in your bound, so maybe. But I tend to bet against it. Really, it's not. It's looking a little weird for polar coordinates. It's probably easiest to do the square roots. Yeah, but you might try it both ways and see which one looks the least painful. Yeah.
If you evaluate that, you get 0, right? Because u and v are all odd functions.
I believe you might be right. Let's see. I want to write this down. Let me think about that. He's right. That is a great observation. So this is okay. Good job. I'm glad you noticed that. Fantastic. When you guys write this down, if you look at all the different terms in that integral, think about which terms are odd symmetric over which lines, and then is your disk symmetric over that same line? And well, the disk is symmetric over all sorts of stuff. And yeah, it does. I believe you're right. I believe it turns out that all the terms are zero by symmetry. Yeah.
Because if you look at the next question.
Mm-hmm.
Wait, how did you realize that?
So if you start looking at what these terms are, let's write this down. So double integral over the disk here, and you've got, so for example, 8u, and then you have minus 2u cubed, and then minus 2uv squared, etc. But a bunch of terms like this. I claim that the integral of this term 8u over the disk is 0 because u is odd symmetric over the v-axis. That function has odd symmetry over the v-axis. And this domain D, in being a disk, is symmetric over the v-axis. And so that the integral of that term is equal to 0. This also odd symmetric over the v-axis. In other words, when you replace u with negative u, this term here becomes the exact negative of what it had been. Again, this is still symmetric. This, well, again, is an odd power of u. This has odd symmetry over the v-axis. And all the terms that you write down have some odd symmetry over some axis. Now, the last term, notice, let's see here, what do we have here? We have plus 2uv and then plus v. This does not have odd symmetry over the v-axis. Because when you replace u with negative u, this doesn't change at all. But it does have odd symmetry over the u-axis. Because when you replace v with negative v, this becomes the negative of what it had been. So you could, for all of these terms, this has all of these have odd symmetry through the v-axis. That term, it's the u-axis. But the domain is symmetric over both of those. So you have to make two separate arguments. This integral is 0 by symmetry over the v-axis. This integral is 0 by symmetry over the u-axis. Does that make sense? So yeah, so fantastic observation, and shame on me for not being on the lookout for my own suggestion. But yeah, this is the kind of convenience you can save yourself very often. So that's a cool example. I probably thought of that when I wrote this problem. But, yeah.
If you look at the next question,
Okay. Yeah.
it's asking to reverse the orientation and see what difference does it make. And because the answer is 0, it doesn't make.
That's right. It doesn't make any difference, and that's just a coincidence.
Oh,
Yeah.
This is the constant.
Well, let's see here. This time.
Because I thought you.
Oh, maybe I did. You know what? Yeah, you're probably right. I probably didn't think about that when I wrote this problem because I was probably thinking this was a non-zero flux, and because I wanted you to see the minus signs. How about that? I might have to change this problem for next time. I don't know. We'll I'll have to think about that. Anyway, but yeah, for number 2, it's the same answer. It's for number 2, the answer is going to be the negative of the answer to number 1, but that's also 0, so same value. Any questions about either one of these problems? Okay, deal.